Hello students, today we will be doing equations of motions. So there are three equations of motions. The number one is v equal to u plus at. So here v means final velocity, u initial velocity, a acceleration, and t is time. So next is s, that means distance, is equal to initial into time plus half into acceleration into time square. So third is v square equal to u square plus 2as. So every terms you know already. So now we will going to derive each and every equation of motion. So here is the diagram, and from here we can write OE is equal to BC, and both the terms can be written as small v, and that is final velocity. And now we can write OA is equal to CD, and that can be written as u, small u, that is the initial velocity. So OC is equal to AD. If you see nicely there in the diagram or in the graph, it is T. So here this axis is velocity axis and this one is the time axis. So now we will be deriving the first equation of motion, that is v equal to u plus at. So I have written here v is equal to u plus at. Okay, now this equation we need to prove, or we need to find out how it has came from the graph. So this equation is also called as equation for velocity time relation. So velocity time relation, the other name of this equation. So here what we can write here, we will start from the change in velocity. We have talked about this in the earlier class. So the change in velocity will be, if you see the diagram here, the change in velocity in time interval t. Okay, so here if you see the diagram nicely here, so we can write what we can write. Where is the change in velocity? BD. BD is the change in velocity. So BD is equal to the total distance is where? BC. So from D it has changed its velocity from D to B, and C to D is the initial velocity. So what we have written, BD equal to BC minus CD. Okay, so the object has reached up to B. Okay, now what we can write here, in place of BD we can write AE, and in place of BC we can write OE, and in place of CD we can write OA. So AE we can compare here the values here. So AE we can write as it is, AE is equal to OE. So here is OE. So V, small v, we can write minus OA, that is small u, that is final velocity minus initial velocity, that will give us the change in the velocity of any object with time t. So here we have got the change in velocity, and now we will use this one in our main part. So using the graph, therefore using the graph, acceleration will be equal to, that is denoted by A. We have seen earlier acceleration A, and what was the formula of that? That is change in velocity divided by the time taken. So this is the formula we have got earlier during the definition of acceleration, and now we will put the values here So a acceleration is equal to change in velocity. So what we can write change in velocity, that is AE, that we have denoted the change in velocity AE, and time taken is OC. So here A is equal to AE. What we can write AE, if you see, we have already got V minus U by OC, means the time t, small t. So now we will be writing small a is equal to, now we will send this small t in the left hand side, so it will become AT equal to V minus U. So again, keeping V as it is, we will send minus U to the left hand side, so it will become U plus AT. So this is our first equation, that is velocity time relation from the graph. Now we will be doing the second equation of motion, that is S equal to ut plus half at square. So if you see the diagram here, we need to find out first the exact distance. So as for distance, so total distance covered by the object, and this equation is also known as the position time relation. So we need to find out that exact distance, exact position of an object. So total distance will be given by this graph if we find out the area of OABC. Yes, if you see the diagram here, OABC. So this area will give us the exact formula for the, or equation for the motion. So area of OABC is equal to, if you see here, there are two parts in OABC. One is the triangle and another one is the, below one is the rectangle. So if you find out the area of triangle ABD plus area of rectangle, that is OABC, we can find out the area of the triangle, area of the quadrilateral OABC. So what we have written the area as AR. Okay, so half into area of triangle will be half into base into height. So what will be the base and what will be the height here? So height will be our BD and the base will be AD plus area of rectangle, length into breadth. So length and breadth will be OC. C into what we can write CD. So CD we can write OA. So again, in the next step, what will be happening here? Half into AD. So AD, in place of AD, I can write OC into BD by OC. Okay. So I have written half into OC into BD by OC into OC. So in order to cancel the OC, whatever I have written in the denominator, for that I have multiplied OC plus OC. We have got T and OA as U from the graph. Okay. Let's go to the equation next step. S equal to half into, after multiplying OC and OC, it has given OC square into BD by OC can be written as A, because BD is change in velocity and OC is the time, plus UT, arranging the TU as UT. So why we have written A, we can write here BD by OC gives us the OC, gives us the acceleration that we have seen in the earlier equation, that is the first equation. BD is the change in velocity and OC is the time. So we are getting the second equation, that is S equal to half into, so in place of OC we can write T, so it will become AT square plus UT. So this is our second equation of motion. Okay. Now we will find out the third equation of motion, that is V square equal to U square plus 2AS. That will be our last and final equation. And this equation can also be called as position velocity relation. Position velocity relation. Okay. So using the graph, we have to find out the distance, that is S. So distance, if you see here, after finding out the area of trapezium OABC, we will be able to find out the third equation of motion, that is S equal to, what is the formula for the area of trapezium, that is half into sum of the two parallel sides, that is OA plus BC, and into the distance between the two parallel sides, that will be OC. If you see the diagram nicely inside the trapezium, so S equal to half into OA, what we can write, U plus, so BC we can write as OE, and in place of OC we can write small t. So S will be equal to half into the initial velocity, that is U, plus in place of OE we are writing V, final velocity, into T. So again we will little bit describe this equation, this step, S equal to half U plus V into T. So as half U plus V, so in place of T what we can write, so we have got the formula A equal to V minus U by T. So after replacing A and T we are getting V minus U by A. So in place of T in the step we can use V minus U by A. So S will be equal to, so we will multiply the denominator, that is it will be 2A, and then after we will be writing V plus U, V minus U. So we will use the formula here, A square minus B square, that is A plus B and A minus B. So using this formula in the step, we again write, after sending 2A in the left hand side we can write 2AS, and V plus U, V minus U we can write V square minus U square. So V square we can keep as it is, and sending minus U square to the left hand side we are finding out U square plus 2S. So this is our final equation. That is the third equation of motion graphically. Okay, V square equal to U square plus 2S. I hope you have understand. Thank you and take care.